Welcome back to section 6.4 on cofactor expansion. In the previous video we talked about minors, and in this video we're going to be talking about cofactors. Definition 6.4.2, let A be an n by n matrix, n greater than 1. Then the ij cofactor of A is Cij, and it is minus 1 to the I plus j times m ij, where m ij is the ij minor of A that we talked about in the previous video. So example 6.4.2, let A and B be as in the previous example, example 6.4.1. We're asked to give C21, C33, as well as the 3,4 cofactor of B. So C21 using our formula here is minus 1 to the I is 2 plus j is 1 times m to 1. So we've got minus 1 to the 3 and m to 1. Well, conveniently m to 1 we calculated up here in the previous example. That was minus 10. So we have minus 1 to the 3 times minus 10. That gives me minus 10 or 10. C33. So C33 minus 1 to the 3 plus 3. So you're always just adding together. You're adding together the two subscripts, times m33, which is minus 1 to the 6th, and m33 was back up here. That was 1, m33 was 1, so minus 1 to the 6th times 1. Even power gives us a positive number. 1 times 1 is equal to 1. And lastly, the C34, the 3,4 cofactor of B. This time, not of A. So the 3,4 cofactor of B, well, that's still going to be minus 1 to the 3 plus 4 times m34, where we're talking about m34 of B. That's minus 1 to the 7, m34 up here, m34 of B was minus 2. So minus 1 to the 7 times minus 2, an odd power gives me minus 1 times minus 2, or just 2. So the cofactors, the bulk of the work is calculating the minors. The cofactors are just minus 1 to the I plus j times that minor. And so you'll notice that we either have the same sign as the minor, or we have the opposite sign as the minor. So Cij is equal to Mij when I plus j is even. So we have an even number. Minus 1 to an even number gives you positive 1. Cij is minus Mij when I plus j is odd. Minus 1 to an odd number gives us minus 1. So in practice, this Cij, I mean, it looks a little weird, it's a little clunky. In practice, most people don't use it. They don't use it explicitly. They do use it. Instead, what they do is they create this checkerboard of pluses and minuses. So where does this come from? Well, you're thinking here that each of these rows are numbered, right? I is not 2 to begin with, I is 1, right? I is the row number, I is 2, I is 3, j is 1, j is 2, and j is 3. And so what each of these pluses and minuses represent is the I minus 1 to the I plus j. For example, this minus 1 right there, well, that's minus 1 to the I is 2, plus j is 3, right? I'm reading those from the row and column. I is 2, j is 3. That's minus 1 to the 2 plus 3. That's minus 1 to the 5. And minus 1 to an odd number will give us a negative. So that's where that negative comes from. So that grid of pluses and minuses is how most people remember the sign that goes in front of Mij. So let's use this grid of plus and minuses to find all the cofactors of this little matrix here, 5, 12, minus 3, 7. So our grid of pluses and minuses, well, if we only have a 2 by 2, we can write out the full grid. So minus 1 is, that always starts in the top corner, always with 1 and 1. And if you add 1 and 1, right, 1 plus 1, you get 2. That's always going to be a positive in that top corner. And the grid then just alternates sign like a checkerboard. So there's our grid of pluses and minuses. Now we want to give all of the cofactors. And so we have the cofactor C11. We're going to have C12, C21, and C22, right? corresponding to the entries 1, 1, 1, 2, 2, 1, and 2, 2. So C11 means that we need to delete the first row and the first column. If we delete the first row and the first column, then we are looking at the minor is the determinant of this matrix here, little matrix 7. Now we need a sign in front of that, and the sign that's going to go in front of that is the 1, 1 entry sign, so positive. Now we've got to remember what's the determinant of a 1 by 1 matrix. The determinant of that is just the entry, so we have positive 7, or, well, just 7. 1, 2, the 1, 2 cofactor. So we're deleting the first row and the second column, first row and the second column. So that means the minor is going to be the determinant of this 1 by 1 matrix, which is minus 3. Now I need a sign in front of it, and what sign am I going to use? Well, I'm going to use the entry in the 1, 2 position of the grid, right there. So that is going to be the minus. So we're going to have minus the determinant of this 1 by 1. In other words, we're going to have minus 3, or 3. Two last ones to do. So C21, we're deleting the second row first column, which is leaving us this little matrix of a single entry, 12. So the determinant of 12, again, we need a sign. Which sign? I'm glad you asked. This one right here. Remember, that corresponds to the 2, 1, the second row, first column, right there. That's the sign that we need. That is a negative, and so we have the negative minor, or negative 12, and lastly 2, 2. So delete the second row, second column. We have this little matrix left, so we're looking for the determinant. This is our minor of the 1 by 1 matrix that has the entry of 5, and the sign that we need is the 2, 2 entry in the grid, so this sign here. So we are looking at a positive, which is going to be positive 5, or just 5. So there's cofactors, there's the grid of plus and minuses. We're going to use these cofactors now to do what is called cofactor expansion in the upcoming videos, and then get to eventually the determinant, the general definition of the determinant using these cofactors.